Alright, we'll start by giving you a little bit of help with the metric staircase. So the very first question, we're going from megagrams to decigrams. So I look up here on my metric staircase. 1, 2, 3, 4, 5 steps. And I took those steps down to the right. So I'm going to move my decimal place 5 spaces to the right. 1, 2, 3, 4, 5. Those empty spots down here can't just be empty. We're going to fill them with zeros. So our number becomes 1, 2, 3, 4, 5, 6, and then I had 1, 2, 3 empty spots. Fill those with zeros. Put my commas in just to help you guys out. 123,456,000 decigrams. Now for the next one, we're going from microseconds to seconds. So look up at our metric staircase. To do that, we're going to go 1, 2, 3, 4 spaces, and this time we went to the left. So I'm going to take this decimal and I'm going to move it to the left 4 spaces. 1, 2, 3, 4. So I'm going to fill those empty spots once again with zeros. So I have 0.000078911011. Very, very tiny number. Next, for precision and accuracy, remember precision means that you're hitting the same point over and over and over again. Accuracy means that you're hitting the right point. So this one here, all of them are tight together. They're hitting the same point over and over again. So that's good precision. They're also hitting the right target. So that's good accuracy. This one is precise and accurate. This one, they're all clumped together, so we have good precision, but they're nowhere near the target, so we've got poor accuracy. For the third one, they're all randomly spaced, so that's not very good precision, and they're none of them on the target, so they're not very accurate. Difference between speed and velocity is that velocity has a direction. North, south, east, west, something like that. Difference between distance and displacement is distance. If this is my start, I might go all around and then finally stop over here. That whole path that I traveled, that's distance. Displacement is going to be the shortest distance between 2 points as the crow flies, is one way of saying it, but the shortest distance if you could travel in a straight line. Alright, speed, velocity, and vectors. So we are traveling east, which is this way, at 2.5 meters per second. The wind is also blowing east in the same direction, and that is blowing 1 meter per second. So if they're in the same direction, I'm going to add them. So 2.5 plus 1 gives me 3.5 meters per second, and velocity has to have a direction, so my direction here is east. Dory is swimming at a velocity of 4 meters per second south, so I'll just point down for south, and that's 4. And the current is going north at 6 meters per second. So they're pointing in opposite directions. I subtract, so 6 minus 4 is 2 meters per second. And think of it like a tug of war. Dory's going this way and she's only got 4. Current's going this way and it's got 6. Who's going to win? The current. So what direction is that going to pull Dory? North. Same way as the current. She's not a very strong swimmer. Alright, on this graph we're going to be looking at position over time, or distance over time. So here, his distance is changing over time. So he's definitely moving. Is he moving forward or backward? We're going to say he's moving forward because he went 4 meters, okay? And then here, the position hasn't changed, but time has changed. So that's like saying time keeps clicking by, but you're staying in the same spot. So you are not moving. A. Here, once again, he's moving forward. The line is sloping up. That means he's changing position as time goes on. And then here, he's changing position again, but he's coming back to 0. So he's going backwards. We'll call that C, moving backward. Sorry about the dorky reference here with Star Wars and Star Trek, but this is a good acceleration problem. So acceleration, if you remember right, from up here, is our change in speed divided by our change in time. So we need to know our speed and our time. So let's look back at our problem. Here's a time, 10 seconds. Here's a speed, 800 kilometers per hour. Here's a time, and here's a speed. So for the Millennium Falcon's acceleration, A equals change in speed, or change in time. So my speed, I've got 1,050 kilometers per hour, and my other speed was 800 kilometers per hour. And my time, I have 14 seconds and 10 seconds. So if I simplify, what I've got here is 250 kilometers per hour in 4 seconds. And you would simplify that down even further to get your final answer. So your final answer there would be 62.5 kilometers per hour per second. Let's do the Enterprise. So once again, acceleration is change in speed over change in time. Here's my time, here's my speed. So I went from 980 kilometers per hour minus 800 kilometers per hour, and then I have 13 seconds minus 10 seconds. So here, simplify that out, 980 minus 800 is 180 kilometers per hour, and it only took me 3 seconds. Simplify that out, that gives me 60 kilometers per hour per second. So who had the greatest acceleration? The Millennium Falcon, because Star Wars always wins. Alright, distance versus time graph, and we're going to remember here.
It was pretty well set up.
Alright, let's calculate slope on a distance versus time graph. First thing you're going to do is you're going to look at your starting point and your ending point, and you're going to look at those coordinates. So this one we went over 0 and up -2. So 0, -2 is our first point. And then over here we went over 5 and up 3. So 5, 3 is our second point. And our formula for slope is y minus y over x minus x. So let's look at our second point. Remember, points are x, y. So we've got 3 minus -2. And then for our x coordinates, we've got 5 minus 0. Remember, if you minus a negative, it's the same as adding. So that simplifies to 5 over 5. Simplify that even further. We've got an answer of 1, and our units are meters per second. Another huge clue here is we're looking at distance over time. Look back up at your formulas. Distance over time is speed. What did we do over here? We figured out change in distance over time. This number, the slope, is the exact same thing as speed. So the slope on a distance versus time graph is always equal to the speed.